You're looking at proving quadrilaterals in the coordinate plane, example 3 and 4. The first one we're going to do is a rectangle. So again, go ahead and sketch your rectangle and label your letters in order, top left clockwise. So G, H, I, J. Write down how you plan on proving it. So remember, for a rectangle, we need to prove that all the corners are perpendicular. So GJ is perpendicular to GH, GH is perpendicular to HI, HI is perpendicular to IJ, and IJ is perpendicular to GJ. What that means is the vertex angles are 90 degrees. So perpendicular means 90 degrees. This is a listening check. Color in the boxes in the corner angles, the ones that say they're 90. All right, so how do I plan on doing that? What do I need? Slope, distance, or midpoint? I need slope. So anytime you're doing parallel and perpendicular, it's slope. So I need to find the slope of GH, HI, and JI and GJ. So the slope of all of those lines. All I did was copy the coordinates down, okay, from the question there, because I'm looking for slope. All right, so what's slope again? Change in y over change in x. So how do I get from 1 to 3? I added 2. How do I get from 1 to 5? I add 4. So change in y over change in x, plus 2 over plus 4. Take care of the signs, that's positive. Simplify that, it simplifies to 1/2. All right, next one, change in y. I added 2. 3 plus 2 is 5. Change in y is plus 2. And then from 5 to 4, I subtract 1. 5 minus 1 is 4. So minus 1. Take care of the signs, it's going to be negative. And then 2 divided by 1 is 2. But I'm going to leave it as negative 2 over 1 as a fraction, and you're going to see why. All right, next one, change in y is plus 2, and that one's plus 4. So plus 2 over plus 4, and that simplifies to 1/2. And last one, 1 plus 2 is going to give me 3. So that's plus 2 is change in y, and then 1 minus 1 is going to give me 0. So that's negative 1. All right, take care of the signs. A positive and a negative is a negative, so it's negative 2 over 1, which simplifies negative 2. But again, I'm going to leave it as a fraction. I'm going to tell you why in a second. All right, so remember that if it's parallel, if the slopes are the same, and it's perpendicular, if you can flip change them, and then they're the same. So look at this. These slopes are the same, which means they're parallel to each other, right? And these other two slopes are the same as well, which also means that those are parallel to one another. But that's not enough to prove a rectangle. That proves a parallelogram. To prove a rectangle, we need the corner angles are 90. So what I need to do is flip the slope and see if they're the same. So looking at GI and GH, flip the slope. So when I flip it, it flips the over and the change of signs. Look at GH and HI. So take 1, flip it. So that's going to be 1 over 2, and then change the sign from negative, becomes positive. So that's perpendicular. Check in the next two. All right, again, flip it. So that's going to be 1 on top, 2 on the bottom. Change that to a positive, and it's true. Last one, IJ and GJ. So flip it. So it's 1 over 2, change the sign, it becomes positive. That's true. Even the other one, flip it, 2 over 1, and change the sign, becomes negative. Doesn't matter which way you do it. So that proves that that's a rectangle. All right, going to look at one more example. We're going to prove that it is a square and find the area. So what is a square? All sides are congruent, and one of the corner angles is 90. Doesn't matter which one. Again, first thing you do is draw a sketch and then put the labels in order, starting top left corner and clockwise. All right, what is your plan? So I need all of the distances the same, and if all the distance is the same, it could be a rhombus. That's why I need to at least prove one corner angle is 90. So I need to prove all the distances are the same, and one vertex is 90. So AB is congruent to BC, BC is congruent to CD, CD is congruent to DA. And one of the corners, AD, is perpendicular to AB. It doesn't matter what corner. You could do AB is perpendicular to BC. It doesn't matter. All right, so let's find those distances. So finding AB, BC, CD, and DA. Listening check, underline, find the area. And that AD is perpendicular, so that's slope. So slope of AD and slope of AB. All right, so let's plug in these numbers. So remember, the distance formula again is in your reference sheet, and all you're going to do is plug in the numbers. So once you copy it down, you're just plugging in the numbers. All right, so AB, open parenthesis, x2, which is 4, minus x1, which is 0, close parenthesis, squared, plus open parenthesis, y2, which is 3, minus y1, which is 0, close parenthesis, squared. All right, BC, so B and C. So B will be 1, C will be 2. Open parenthesis, x2, which is 7, minus x1, which is 4, close parenthesis, squared, plus y2, which is negative 1, minus y1, which is 3, close parenthesis, squared. Now you're going to do CD, C being 1, D being 2. So open parenthesis, x2, which is 3, minus x1, which is 7, close parenthesis, squared, plus open parenthesis, y2, which is negative 4, minus y1, which is negative 1, squared. And last one, dA, a being 1, d being 2, because the order doesn't matter. x2 being 3 minus x1, which is 0, close parenthesis, squared, plus open parenthesis, y2, which is negative 4, minus y1, which is 0, close parenthesis, squared. Alright, for slope, change in y, so that's going to be negative 4 over, and then from 0 to 3 is positive 3. Simplify, negative and a positive give you a negative, so it's negative 4 over 3. And then change in y here is going to be plus 3. And I wrote minus 3, but it's plus 3, and then plus 4. So plus 3 and plus 4, which is going to be positive. And I'm going to come and correct it because I realized my mistake in a little bit. Alright, so remember, to find perpendicular, you have to flip it and change it. And if it's the same, then it's perpendicular. So I've corrected my mistake. So flip that. 3 goes on top, 4 on the bottom. Change the sign, becomes positive. So yes, it's perpendicular. Let's punch all of these into the calculator and see if they're equal. All of them have to be equal. So square root, open parenthesis, 4 minus 0, close parenthesis, squared, plus open parenthesis, 3 minus 0, close parenthesis, squared. Make sure it matches, 5. Listening check, color in the sketch of the square ABCD. Now you're going to do this for each one. Remember, try to do it as well at home because this is practice. You're going to check your mistake with my calculator. You're going to make sure that it lines up with what it is, because all it is plugging in numbers. Just remember the negative is next to the decimal. The listening check, go ahead and circle all the answers with the distances, all the 5s. Last one, open parenthesis, 3 minus 0, close parentheses, squared, plus, open parenthesis, negative 4, minus 0, close parenthesis, squared. Matches up, enter. 5. Alright, so all of the sides of this square are 5, and it's perpendicular, therefore it's a square. If you only proved all the sides are equal, then it could be a rhombus. Alright, now we have to find the area. So now that we have the distances, well, the area of any square is base times height. The base is 5, the height is 5. So it's 5 times 5, which is 25. So sometimes they throw in that question where they give you coordinates and tell you to find the area. So remember, it's really 4 things for every single question except a square, which will be 5 things. So to be doing 4 calculations, a square is 5. Let's practice.